So the next main type of chemical bond is called an ionic bond. You can see in the picture that two atoms are together, and what is the one atom doing? It is proposing to the other, meaning it's going to give its ring and she will take it. So it's a give and take type bond. So just like we said that a molecule was a covalently bonded group of atoms, you can also have an ion. An ion is a group of bonded atoms that have a positive and negative charge. They come together and they form an ionic bond. So you should know by now that opposites attract, the positive and negative attract, and they cancel each other out. So they do have a charge to start, but once they bond, it becomes neutral as well, just like the molecule. There are two types of ions. You can first have a cation, which has a positive charge. You have to remember that electrons are negative. So a cation is formed by losing one or more electrons. If you lose an electron, you lose negativity. Therefore, the atom becomes more positive, forming the positive ion. And the way I make students remember this is to think of cats are positive. Like pause on a cat. I know it sounds crazy, but you'll probably remember it. The other type of ion is called an anion. This is a negatively charged ion. It is formed by the addition of one or more electrons. Remember again, electrons are negative. So if you add electrons, you're adding negativity and becoming more negative. And the word anion is very close to the word onion as far as spelling goes. And onions make you cry, which is bad. So anions are negative because onions are bad. Cations are positive. Keep those straight. So an ionic bond forms from the transfer, the give and the take, between a cation, a positive ion, and an anion, a negative ion. So these positive and negative ions attract, they transfer and give and take electrons, and then they're bonded. There is not an overlap occurring, but a give and a take. So once again, the octet rule says that every element wants 8 electrons in its outermost shell, besides hydrogen and helium. So sodium has 1 electron in its outermost shell. It has 1 valence electron. It is in group 1. Chlorine has 7 valence electrons in its outer shell. It's in group 17. Chlorine needs to get 1 more electron to be stable, and sodium needs to lose an electron to be stable, because once the shell is empty, it goes to the next shell, which has 8. So sodium is going to give its electron to chlorine. Chlorine will accept it. The outer shell is empty in sodium, so it disappears. So now sodium has 8 electrons. It is happy. It has lost an electron, so it is positive. Chlorine has gained an electron to now have 8. It's gained negativity, so it is negative. Negative and positive come together, and they sit side by side in an ionic bond. Remember back to chapter 5, we also said that if you have a group 1 or 2 metal reacting or bonding with a group 17 nonmetal, it forms an ionic compound called a salt. That's because group 1 metals, most likely you can have a group 2 metal, but it's a little bit trickier. Group 1 metals, the alkali metals, have 1 valence electron to give, and the halogens in group 17 have 7 valence electrons, and they need 1 more. It's a very easy exchange, and that's why they bond very easily, and we call it salt. So sodium, as we just said, gives to chlorine, and sodium and chlorine form sodium chloride table salt. So once again, this is just showing you what happens, and I have a video that kind of explains it in detail a little bit more so you can visually see what happens. So watch his hands, not his face.
This video is an introduction to ionic bonds and ionic bonding. Don't know anything about these things, or you feel a little bit rusty? It's no big deal, because we're going to start from scratch. So, ionic bonds are one type of chemical bond. Chemical bonds are like glue that holds atoms together. Okay, like here are two atoms that are bonded together, they're connected, they're glued. Now, ionic bonds are the type of chemical bond that hold together metal atoms with non-metal atoms. Okay, so if you look at a periodic table, there's this big, thick staircase over on this side. And this staircase separates the metals, which are all the elements on this side, from the non-metals, which are most of the elements on this side. So whenever we have a chemical that has a metal connected to a non-metal, that's held together by ionic bonds. So some examples are silver chloride, magnesium iodide, or aluminum oxide. Each one of these chemicals have a metal, this one, or this one from this side of the periodic table, with a non-metal, this one, or this one from this side. So ionic bonds in all these because there are metals and non-metals connected together. Okay, so now we're going to talk a little bit more about the how and why that's going on with the bonding here, right? It's like, how do these atoms actually connect together? What's holding them? That's what we're going to talk about next. Okay, so to learn more about ionic bonds, we are going to focus on a chemical called sodium chloride. Sodium chloride is a fancy scientific name for table salt. It's the stuff that you put on your food. So sodium chloride is made of two types of atoms. We got sodium. Here's its symbol from the periodic table, and here is a sodium atom right here. And sodium chloride is also made of chlorine or chloride. I'll tell you what the difference between those is in a minute, but you don't have to worry about it right now. And here is here's a chlorine atom. Now, sodium chloride happens when these two atoms come together, when they're glued together by ionic bonds. But the atoms that I have right here, they're not glued together. They're just kicking it over here. They have nothing to do with each other. So I want to talk about what happens to get these separate atoms connected and glued together, like these. How we go from this to this. I'm going to tell you the kicker. I'm going to tell you the end of the story now so you can follow it through as we talk. The reason why these two atoms are connected is because they end up getting electrical charges. Okay, this atom is going to end up getting a negative charge, and this atom is going to end up getting a positive charge. What do oppositely charged things like to do? They like to attract. And so because these things get different electrical charges, they are going to be held together by those different charges attracting. Okay, so let's look at the steps. Get different electrical charges, they are going to be held together by those different charges attracting. Okay, so let's look at the steps that we have to take to go from this to this. The first step is pretty much what I got right here. We're starting with two separate atoms that aren't connected. We got the metal atom, the sodium here, and the non-metal atom, the chlorine, over here. Now the first thing that happens on the road to an ionic bond is that the sodium atom gives one of its electrons to the chlorine atom. Here's the electron moving between the two of them from the sodium to the chlorine. Now this electron moving will change the charges of these two atoms. Okay? That's what happens in the next step. Sodium gives away one of its electrons to the chlorine, so it loses one electron. It has one fewer electron. And that's going to give it a positive charge because it lost an electron. But chlorine gained one of the electrons from sodium, so it's going to become negative. It's going to get a negative charge because of that extra electron. So now, these two atoms take on electrical charges. And what do we call atoms that have charges? We call them ions. This one's a positive ion, sodium becomes positive, chlorine becomes negative. Now here's where the difference between chlorine and chloride comes. Chlorine is what we call the chlorine atom when it's neutral. So up here, this non-metal atom, chlorine, just hanging out here, is chlorine, 0 charge. But down here, after it's received one of the electrons from sodium, it gets a negative charge. It becomes a negative ion. And now we change its name just a little bit. We call it chloride. So it's the same atom, chlorine and chloride. They're the same.
Okay, that's getting a little farther into the next chapter, but so hopefully that kind of visually gave you a little bit clearer picture of ionic bonds. So last thing is just to compare and contrast ionic versus covalent bonds, just so you see the similarities and the differences. So how do electrons attract? Well, in covalent bonds, they are shared, but in ionic bonds, they are transferred, given and taken. Are there any variations of the bond? In covalent bonds, we have polar and nonpolar, where the sharing is either unequal or equal. Ionic bonds do not have any variations. What elements are present in these bonds? Covalent bonds are usually similar elements, identical, or those that are close together on the periodic table. And ionic bonds are usually a metal and a nonmetal. Okay, so then the last thing, I would show you this if we were in school, and I will show you eventually if you're in person, but covalent bonds are poor conductors of electricity. Ionic bonds actually can conduct electricity, but the bond, the substance has to either be melted or dissolved. Dry, it will not do anything, but when added to water, which is polar, it helps it conduct. So one quick video just comparing the two again, and hopefully you will understand the difference between ionic and covalent bonds.
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by two atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
So the moral is if dogs can learn chemistry, so can you. So now you have learned about two of the three main types of chemical bonds.